Welcome back to The Explainer. So, have you ever just stopped for a second, looked at your daily routine, or maybe a project you're working on, or even just the literal layout of your desk, and thought, why does this all feel so overwhelmingly chaotic? Like, why do we constantly feel this uncontrollable urge to pile more tasks onto our to-do lists, cram more features into our apps, and squeeze more meetings onto our calendars? Well, hit pause for just a second because I am about to deliver a slightly sarcastic, but honestly deeply comforting reality check. If your life feels like a tangled web of massively over-engineered systems, it is not a personal failure. You aren't just bad at organizing. No, your brain is quite literally wired by evolution to make things harder than they actually need to be. I mean, think about it. We see this chaotic montage of overcomplication everywhere. We've all struggled with that absurdly bloated software update that somehow added 50 unnecessary buttons when literally all you wanted to do was crop a photo. Or, what about that one kitchen drawer? The one stuffed with 10 highly specific plastic gadgets when a single decent knife does the exact same job? Or, my personal favorite, writing a massive 5-page email explaining a concept that could have easily been summarized in one single punchy sentence. Or staring at an aggressively overscheduled digital calendar that leaves absolutely zero room to even breathe. Okay, let's dive into this because the science behind why we do this to ourselves is absolutely fascinating. First off, we have to realize this isn't just some new internet age problem brought on by smartphones. A recent paper published in the Nature Portfolio journals highlights this famous historical quote from the philosopher Blaise Pascal. He once wrote, "The present letter is a very long one, simply because I had no leisure to make it shorter." See, Pascal knew centuries ago what researchers are proving today. Simplicity takes actual cognitive effort. The researchers in this study defined this exact phenomenon as the addition bias. You'll sometimes hear it called subtraction neglect. In snappy terms, it's basically a systematic cognitive preference for additive transformations over subtractive ones. Meaning, when we are faced with a problem, our brain's default lazy setting is to just add elements, more words, more parts, more rules, rather than taking things away. To test this out, earlier research used a hilariously simple metaphor, a wobbly Lego tower. So imagine a person trying to fix a Lego tower that's unstable. The study showed that people will clumsily add more and more bricks to the base, making the structure wider and bulkier, completely ignoring the fact that just removing one single unstable brick from the bottom would instantly solve the problem. And this brilliantly illustrates the spatial experiments researchers used to prove our bias in a highly controlled setting. They gave participants what's called a grid symmetry task. The goal was simple: make the pattern perfectly symmetrical from left to right and from top to bottom, using as few changes as humanly possible. So participants could either toggle empty boxes to become filled, which is adding, or erased filled boxes, which is subtracting. And guess what happened? When asked to make these grids symmetrical, the overwhelming majority of people's very first instinct was to add shaded boxes to match the other side. This happened even in scenarios where simply erasing a few boxes was mathematically faster and required fewer steps. But here is a really crucial finding about human behavior. We're biased, sure, but we aren't completely blind. The study manipulated the efficiency of the task, and they found that while humans absolutely suffer from addition bias as our default go-to, we actually do possess the cognitive control to adapt. When subtraction became glaringly, obviously more efficient, human participants paused, calculated the effort, and actively chose to subtract instead of add. Part 1, the surprising AI twist. So what actually happens when we introduce non-human intelligence to the mix? The researchers decided to run these exact same spatial and linguistic problem-solving experiments on artificial intelligence. Which naturally leads us to the ultimate question. Do generative AI models make more rational decisions? I mean, you'd probably think that highly advanced, emotionless models like GPT-4 and the newer GPT-4o, systems capable of passing the bar exam, would easily overcome this deeply human cognitive flaw, right? They don't get tired. They don't get emotionally attached to Lego bricks. Well, boom, time to drop the truth bomb. The AI is actually worse. The data clearly shows that AI models amplify our human flaws. While humans showed a moderate addition bias, GPT-4o hit extreme ceiling levels, choosing addition nearly 100% of the time in certain conditions. The bias isn't just mirrored here, it is literally on steroids.
So, the absolutely crucial point here is that human and AI problem solving fundamentally diverge. The human brain, as we saw, pauses, uses a sort of cost benefit integration, and finds an efficient shortcut when one exists. The AI brain, on the other hand, it just blindly sticks to adding elements, completely ignoring the structural efficiency constraints. It just piles on more and more and more.
The data breakdown reveals a massive 95% bias. GPT-4o chose an additive strategy even in the experimental condition where subtraction was deliberately designed to be wildly more efficient. It completely failed to recognize that it should just remove elements. Just picture a highly advanced robot scratching its metallic head, voluntarily burying itself under mountains of digital paperwork simply because it literally doesn't know how to throw anything away.
So why does a literal supercomputer fail so spectacularly at subtraction? The researchers point to what they call the linguistic trap. AI inherits this bias directly from its training data. And what's that data? It's all of our written language. In human culture, words like more, higher, and adding are heavily associated with positive outcomes, status, and creativity. Meanwhile, subtraction is wrongly associated with a loss or a lack of effort. Now, what's really interesting about this is how they proved that linguistic connection. The researchers gave the AI two different prompts. One was a neutral framing, just asking the AI to change a pattern. The other was a positive framing, asking the AI to improve the pattern. Simply changing that one instruction verb completely altered the AI's behavior in the linguistic tasks. The data revealed that giving an AI a positively balanced instruction like improve or optimize essentially acts as a trigger warning that guarantees it's going to bloat the output. Positive words make AI overcomplicate things even more, pushing its additive choices right up to absolute ceiling levels. The AI just assumes that to improve something automatically means you have to add to it. Part 2, the subtraction audit. Okay, if both our human brains and our absolute most advanced AI tools are actively working against simplicity, we need an actionable life hack to fight this. We need to transition to a cleaner, minimalist aesthetic in our own day-to-day decision-making. First, we really have to recognize that this isn't just some fun lab experiment with grids and Legos. It is a society-wide glitch. The researchers note that this macro addition bias plagues massive industries. In healthcare, the focus is so often on adding more drugs rather than stopping harmful behaviors. In environmental waste, we hyper-focus on recycling, which is an additive process, rather than simply reducing waste generation in the first place. And in tech, well, we get software that basically requires a supercomputer just to open a text document. So, to run your very own subtraction audit, you can follow these steps directly from the science. Step 1, stop your heuristic memory search. That is, your brain grabbing the absolute fastest, easiest idea, which is almost usually adding. Step 2, explicitly cue subtractive options. You actually have to force yourself to look for things to remove. And step 3, enjoy the satisfaction of the purge. Delete the unused apps, clear the clutter off the desk, and violently, wonderfully cross out those unnecessary tasks. We really have to consciously rewire our whole problem-solving approach. Subtraction isn't a loss, it is an optimization. So I want to leave you with a counterintuitive thought. Next time you try to fix a problem, streamline a project, or just get your life together, don't ask yourself what you need to add. Ask yourself, what can I destroy?